Okay, so these notes are on the sum and difference identities we started in class the other day. So first of all, you guys can scroll through the video, but there are 6 formulas. One is sine and cosine, the addition and subtraction. Then we have, we have sine, addition and subtraction, cosine, addition and subtraction, and then tangent, addition and subtraction. So I'm going to go over an example with you guys for sine, and let's see here. We're going to do the second problem from your homework, sine of 11 pi over 12. So first of all, this is in radians. We know it's in radians because it doesn't have a degree symbol. Just because you see pi doesn't mean it's in radians, okay? The degree symbol tells you whether it's in degrees, and if there's no degree, that means it's in radians. So I'm going to write down some steps over here on the right. And first thing is that I don't want to work in radians just because it's easier for me, at least, to work in degrees. So I'm going to change my angle from radians to degrees. Change from radians to degrees. And to change from radians to degrees, you guys should remember that you multiply by 180 over pi. So 11 times 180 divided by 12, that's 165. So I'm going to come back over here, and I'm just going to write everything out kind of like we did with our proofs. Okay, the left side equals, 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 equals until we get to the end. So I know now this equals sine of 165 degrees. Now the problem is that 165 degrees is not on the unit circle. So what we're going to do is we're going to find 2 angles that are on the unit circle that add or subtract to be 165. So find 2 angles on the unit circle that add or subtract to give 165. Okay, so I'm going to do 210 and 45. 210 degrees minus 45 degrees is 165. So I'm going to come over here and say, okay, this equals sine of 210 minus 45 degrees. Now notice how we have this formula up top that says sine of alpha minus beta equals blah, blah, blah. And so now we have sine of 210 minus 45. So it looks just like this formula. Our alpha is 210 and our beta is 45. So everywhere you see an alpha, you're going to plug in a 45, and everywhere you see a beta, everywhere you see an alpha, you're going to plug in 210, and everywhere you see a beta, you're going to plug in 45. So my third step here is plug into formula. Okay. All right. So sine 11 pi over 12 equals sine 165 equals sine 210 minus 45 equals, and I'm going to substitute in. So equals sine of 210, and that comes from this part here, times cosine of 45, and that comes from that part there, minus cosine of 210, and that's from that guy there, and then times sine of 45, and that's from this last guy here. And now technically I need degrees on all of these because we're in degrees, so I'm going to go ahead and put them in. Bless you. All right, now third step here, or fourth step, is evaluate. I'm running out of space. Evaluate and simplify. So sine of 210, luckily 210 is on our unit circle. 210 is down here. And I want to know the sine of 210, so cosines x, sines y. So sine of 210 is negative 1/2. So I'm going to say this equals negative 1/2. cosine 45, well 45's over here, cosine's the x, so times square root 2 over 2, minus, now we come back to 210, cosine is negative square root 3 over 2, so negative square root 3 over 2, times, and then sine of 45, come back over here to 45, and that's square root 2 over 2. Now I just simplify, this becomes negative square root 2 over 4, subtracting a negative makes that addition, so square root 6 over 4. And because they have a common denominator, you can write this as negative square root 2 plus square root 6 all over 4. So what we've shown is that this first value here, sine of 11 pi over 12, equals negative square root 2 plus square root 6 over 4. Okay? Now depending on what trig function you're using, you're going to have to choose the formula that you want. So you guys can go ahead and copy down. You can pause the video and copy down your formulas. Okay, next one I want to look at is number 7. So number 7 is kind of working backwards. So if you look at this problem, what you'll notice is that it looks just like the sine formula. Okay, sine of alpha plus beta. Sine alpha, cosine beta, cosine alpha, sine beta. Okay, so this looks just like sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. So if you notice, what's happening here is your alpha is just pi over 6. And your beta is pi over 12. So I'm just going to work backwards. I'm going to say, okay, I know that this equals sine of pi over 6 plus pi over 12. When you add those together, get a common denominator, so times 2 times 2. So this is 2 pi over 12 plus pi over 12, so 3 pi over 12. And I know 3 pi over 12 is just pi over 4. And if you look on the unit circle, sine of pi over 4 is square root 2 over 2. So what we've done is we've shown that this first part, our original problem, this guy, equals square root 2 over 2. So these are actually easier. They look more complicated, but they're actually a bit easier than the other problems. Okay, now let's do one of these verifies on the back. We'll do an easy one. Let's just do the first one here. So first one says sine of theta plus pi equals negative sine theta. Now, I'm going to be really, really picky with you guys when you are writing these proofs. If you do not do it properly, you're going to get points taken off. So remember, you're starting with the left, and you're trying to prove that it equals the right. So I'm going to start by writing down the left, sine of theta plus pi, and I'm going to say, okay, that equals what? So I notice this is an addition formula with sine. So you go back and you look at your formulas here. Addition for sine is this first one, sine alpha cosine beta plus cosine alpha sine beta. Okay, I'm going to write it down here just so you have it to think about. Sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. So now for this problem here, just notice that theta is your alpha and pi is your beta. And so all you're doing is you're just plugging it in. So this equals sine theta cosine pi plus cosine theta, right, yes, sine pi. And I'm going to say that equals, well, cosine of pi, think about your unit circle. Pi is over here, and that point is negative 1 comma 0. So cosine of pi is negative 1. So what we have is sine theta times negative 1 plus cosine theta, and sine of pi is 0. So times 0. And all of that equals negative sine theta plus 0, because cosine theta times 0 is 0, so that equals negative sine theta. And so in the end, I'm going to say, so sine of theta plus pi equals negative sine theta. So notice that this first part equals this last part. We're done. And that's it.